All right, so the first thing I usually do is I go to uh, my question pool in Blackboard, right? I've had a bunch of multiple choice questions, and I want to change a lot of them over to um, questions that have different values um, for different students. In the past, we used an LMS called Angel, and we could easily write algorithmic questions. Now, you can also write algorithmic questions in Blackboard, but the problem is I can't have I can't have multiple questions referring to the same set of random data. So it makes it a little more difficult. So a colleague and I decided to uh, start writing our questions in Excel and then importing them into Blackboard as, um, as a text file. His process is a little different than mine. I find my process easier. That doesn't mean that his is wrong. It's just that it's what I've become comfortable with, right? And so, for example, the first um, thing I might do then is I might find some questions here, and some are easier than others, right? Um, to convert to um, these kinds of questions. A lot of them are probably true false or fill in the blank uh, or something like that. And so let me let me see if this is what I'm looking for. Eventually, I have to convert a bunch of these, right? And so here it looks like we have some, maybe we start with an osmotic pressure problem. So the first thing I might do then is I'll look at this question and I'll say, okay, so how can I change that so that it's not a multiple choice question, right? And so I don't know if I can copy that. And so I might copy that just to have it, okay? So I copy that, and then I might go to Excel, uh, and so let me go to Excel, okay? And so I've copied the question I'm interested in. So then I go to Excel, and I might paste it here just so I can see the question. And so here's the question that I want to create. And so it looks like I've got several variables, so I can have this, a certain number of grams of an unknown compound. I could change up the volume, and I could change up the osmotic pressure, and I could even change the temperature then. So I've got what, one, two, three, four different random variables I could put in. And so probably generating 500 of these questions should be pretty easy. And so for whatever reason, I never like to start up in A1, right? I might need some room or something like that. And so, and I usually don't like to start a question with um, a number. So maybe I'll start here in cell B4. So writing your questions this way, part of it you have to uh, know a little bit of HTML so that you can format your questions as you go along. And if you don't know HTML, it's okay. There are some websites that I could direct you to as well. So I might start with a paragraph tag, and then I might say an unknown compound with with maybe a mass of, then I'll put a space. And so now, at this point, I'll have to make, and that kind of gave me too much room there. So I'll back it off here. And so now in cell C4, I can put some kind of a random variable. So I don't know, 0.1 grams. So maybe I could go between, I don't know, maybe 0.1 and, I don't know, 0.3. Okay. And so I would say equals rand. So there's the rand function. And in fact, let's put it out in front there. So I just moved my cursor in front there. And so I would say, and so I could say, well, let's see, I want it to be between 0.1 and 0.3. And so I could say, well, let's multiply this. Oops, let's multiply this rand function by 0.2. And then onto it, I could add 0.1. And so that is going to give me a range then between 0.1 and 0.3, right? And maybe I would want to round that number to a certain number of significant figures, but I generally don't do it in this cell. I'll generally do it in the cell next to it. And so up here, I might say mass, just to remind myself that that's the mass. And over here, I might say text, just to remind me that that's the text value. And so I'll round that value then after over here so that I can use it when I export the question. But I'll always use the value C for when I do the calculation. And so here I could ensure that I always have 3 places past the decimal, even if there happens to be a 0 in that 3rd place, I could actually force it. And so I would say equals text. And so I would take the value in C4. So there's C4. And if I want it to have 3 places past the decimal, no matter what, I go 0.000, close the quote, close the parenthesis, and there we go. Okay, and so so at this point, an unknown compound with a mass of 0.133. Now if I just started typing here, that value is going to be tucked up right next to the 3. So of course, we'll use a space then. And so I'll go space, and then you could put in G for grams. Well, personally, I like all of my units in italics. It's up to you. It's less typing if you don't. I just think it looks a little cleaner when I do. Italics tags. So unknown compound with a mass of 0.133 grams is dissolved in space, right? So there's the next part of the problem. And now I can choose a random number of milliliters, right? And so I could say, oh, I don't know, equals, well, if I go maybe between 100 milliliters and, well, why not between 300 again, I guess. Okay, so we could go, and so I multiply that rand number then by the value of the range. So if I want between 100 and 300, I would multiply this by that rand by 200. Okay. If I wanted from 100 to 500, then I would multiply that rand by 400, right? 500 minus 100. And then I always add to it the value of the lowest range that I want, and so I want 100, and so there's my value. So that gives me that, and I could also then round that to no places past the decimal. I could use that text function again. In this case, even if it's 100, it would still give me that last zero, so I could just round it. And so maybe I'll do that. And so I would say equals round, and I want to round F4 to 0 places past the decimal, right? And we've set it up so that F will always have 3 significant figures. Although technically, right, if it does end in a 0, your students might say, oh my God, that's only 2 significant figures or 1 significant figure. This is why I also tell students, I instruct them what to round their answer to. Okay, so here's 224. Well, and so now it's milliliters, so space, and again, italics, because that's just a personal preference, 224 milliliters of water, and has an osmotic pressure of, okay, now it's time for the next, right? Now it's time for the next bit of the equation. And so now we could have a random osmotic pressure. I don't know, this was on the order of 28. You know, I gave the mass a range of about 3 times what this problem was. I gave the volume a range of about 3 times what the volume was. I suppose I could give the osmotic pressure a value of about 3 times the range, right? Just to kind of keep all of the values sort of in a manageable number. Now, it's up to you. I mean, you could stretch that range if you wanted to, right? You just have to be aware that you might have to do a little massaging to get the answers in the range that you want. Okay. All right. It has an osmotic pressure of, okay, so let's say equals, I don't know, let's go maybe from 25 to 75. And maybe this time we'll include 1 place past the decimal, right? So 25 to 75, that would be 50 times rand plus 25. That gives us that. And so now we could round that to 3 places or 3 significant figures. If it's always going to be, right, 2 places in front of the decimal, so we know we could round it to just 1 place past the decimal. Now, again, if it rounds to a 0, it might be a little cumbersome, and so we could just say equals text I4, and so if I want 1 place past the decimal, I can go 0.0, and that should round us to the correct number of significant figures. Oops, and I forgot to remind myself, right? So here's volume, and here's the text for it. Notice the numbers do change when I change things, and here's the osmotic pressure. If I can spell osmotic pressure, and maybe I'll just go osmotic P, and so then here's the text for that. Okay, and so now we need the units, and so space, italics, millimeters of mercury at, and there's a space at the end, right, so that it doesn't bump up against the temperature. And so now I can have a random temperature here. Okay. And then I also make sure that when I see a problem, if I've got something like this, whoever wrote this problem, right, there should always be a space between the number and the unit. They forgot, so I make sure that I don't copy that. So at, and now some temperature. And so let's remind us, this will be the temperature, and this will be the text value. Let's see, so what do we want for the temperature? I don't know, something reasonable, right? Maybe 15 degrees C to 30 degrees C, okay? So let's see, 30 minus 15 is 15, so equals 15 times rand plus 15, okay? So there's that, and so now we can round that to one place past the decimal. And so we'd go equals text. This time it looks like L4. Okay, and there we go. And so now we have to put the temperature unit on there. And so space, italics tag. For degrees C, I generally then use the HTML, so and degree semicolon, right? So that's the HTML for a degree. And then I would have C, and then I can close that italics tag and put a decimal point, okay? And then it says, so calculate the molar mass of the unknown compound. And I generally tell the students then what unit I want that in. So I would say calculate the molar mass of the compound in, okay, open in italics, grams per mole. And then I can close the paragraph tag. So this problem, the problem is written, then I generally give them some instructions. And so I would open another line. So here's another paragraph. And then the instructions, I start another paragraph. And my instructions, I just always put in italics. And so then I tell them, report your answer to 3 significant figures. And then close the tags. All right. So at this point, the problem is written, right? But now we have to calculate the answer. Okay, so at this point then, we could just start to key in the formula for the answer. I did forget over here though, usually I also tell them what value of R they would have to use, and then I also tell them the conversion for millimeters of mercury to atmospheres, right? And so I would include here then, I would say R equals 0.082058 liter, right? Liter atmospheres, it has that little dot in there. And so for HTML, that's an S dot, so and S dot. So liter atmospheres. divided by mole S dot Kelvin and 1 atmosphere equals 760 millimeters of mercury. Okay, period. All right. So I give them that information. And then right after the problem here in cell O, I put some kind of separator that I know I'm not going to use in the problem. And I do this so that we can then take all of this into a text editor and easily set it up the way we need to. And so here's my separator. This will be my answer, and then this will be my answer with significant figures. Now, the way Blackboard is set up, it's going to look for the problem, it's going to look for the answer, and then it's going to look for some error. You don't have to put some error on there if you don't want to, but I generally do. So I'm just going to put another separator there. And so then here's the error, and here's the significant figures for the error. Right, and so then I also always do the problem, right? So I set it up ahead of time so that I can just key it in. And so if you've done the problem, right, we need the mass. And so let's find where the mass is. And so we said the mass is in, over here in C. And so it looks like C4. And it'll be divided by the osmotic pressure and the volume. Oh, here's the volume. So let's just divide by F4. So divide by F4. I also have to divide by the osmotic pressure. And so here's the osmotic pressure in I4. But we have to remember that that's in millimeters of mercury, right? So we need to convert it to atmospheres. So if I take the osmotic pressure and divide it by 760, that should give me the osmotic pressure in atmospheres. Okay. Let's see. So I'm actually just kind of writing this down while I'm talking to you. So there's the volume. Here's I4 divided by 760. And then we would multiply by R. And so times R, and then we have to multiply by the temperature. But the temperature, remember, has to be in Kelvin. And so we would take the temperature is in L4, and I would add 273.15 to that. And however you teach your students, that's up to you. I always tell them use 273.15. It's probably the physical chemist in me. Okay. All right, so we can do the math then. Okay, and so now we can put our answer, key our answer formula in, and I usually write it out ahead of time so that and if something goes wrong, I can go back and look and kind of see where I went wrong. And so when we do the problem out, it looks like molar mass is going to be what? Grams times the gas constant times the temperature divided by the osmotic pressure in atmospheres and divided by the volume in liters. Okay, and so we have to make sure that we make those corrections. So if I change the osmotic pressure to atmospheres, well, it means I'll take the millimeters of mercury, divide by 760, which is the same as what? Putting it up on the top of the fraction here. If I change the volume, which is in the denominator here, to liters, well, I would take the milliliters, divide by 1,000. So that's putting the 1,000 up in the top of the fraction. And so now we should be able to, let's see, our mass was in what? Our mass was in C4, okay? And so we would have times C4 and the gas constant, so times 0.082058. And if I suppose I could have put this in the gas constant in a cell by itself and then just reference that cell all the time. Either way is fine, either way works, okay? Times temperature, and we have to convert that to Kelvin, so we would take L4 and add 273.15, close that. Now we can divide by the volume, so F4, and divide by the osmotic pressure, I4. Okay, so divided by F4 divided by I4, and that should give us the answer that we're looking for. Okay, and so there's the molar mass. So now, if you want to convert this to significant figures, there is a way to do that, and it's a long formula. I just happened to find it on the internet, right? The web is your friend, and so we would have equals round. What are we going to round? We're going to round our answer, P4. We want to round it to 3 significant figures. And so usually this round function, if I put a 3 here, it's going to round it to 3 places past the decimal. So I don't do that. I go 3 minus, open parenthesis, 1 plus, and then I go int log absolute value of P4, close parenthesis, close parenthesis, close parenthesis, and one more time, close parenthesis. Oh, maybe more than one more time. There we go. Okay, so if I do that, it should round that answer. It'll probably change on me, so I won't even give you the answer. So, right. So, but there's rounded to 3 significant figures. Okay. For the error, I can do the same thing. Now, it's up to you. If you think they should get the answer exactly, don't put any error in. I usually give them about a 1% leeway. You could make it more. Sometimes I'll give them 2%, right? But usually it's 1%. And so I would say in S4 then equals 0.01 times P4. So there's my error. But we never report error that way, right? We usually report error to 1 significant figure. So I'm just going to copy this. I'm going to come over here and paste it. Well, that gives me 3 significant figures for that, right? But I can easily come up here, change that to a 1. And now I've got my error to 1 significant figure, about 1% of my answer that I'm looking for. All right, so we've got the problem coded. We've got the answer ready. And so now we have to kind of put it all together. But at this point, this is only one version of this problem, right? So if I come here and I select the whole thing, I can now drag this down as many times as I want. I'll just do it for a few, just for the demo. But right here's, here's, I don't know, how many is that? 19, something like that. Right, so I've got all different, here's different values of the osmotic pressure and the volume and the mass, right? All in those ranges that we decided. Okay, so the form it's in right now, though, is not very useful for us, and so I might give this some name that I know what it is. I'll just call it pi for osmotic pressure. This sheet is where we put it all together. Let me make that a little bigger. Oops. Okay. And so I would call this pi concat because I'm going to concatenate that row. And so I might start here. Now this kind of problem, Blackboard wants to see a certain format. And so it wants to see, okay, this is a numerical problem. All right. So now let's put everything together. So equals concat. And so now I come back to my sheet, and I know that I want this. So I'm going to click here, put a comma. This is what I want them to see. So I'm going to click here, put a comma, 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 comma. Make sure you include your separator, comma, comma, comma. And now I can close with my parenthesis. So I hit the, so now here's my formatted question with HTML tags. And I usually check to make sure that all my spacing is right. And if it isn't, it's easy to just go back in and do what you need to do. So it looks like everything is okay. I forget how many of those I had. I think I started at 4 and went to 18. So I'll start at 3 and go to 17. And so now here I can just copy those down. So now all of my problems are there. Okay. Okay, so at this point we need to get this in a form that's usable for Blackboard. So I come here and copy this, right? Because everything, all the text and everything is just in that B cell. So I copy those, okay, and then I can come in and paste into a text editor. So I do that, and I haven't saved it yet. So my text editor that I use is called BBEdit, and it happens to say, oh, look at all of those HTML things. Well, I don't need the HTML, or I don't need it to recognize the HTML. So I'm going to go ahead and save that, and I'll just save it. Oh, I should probably, I'll just save it right here for now. Okay, so let's call it osmotic pressure dot text. As soon as I save it as a text file, all of the HTML colors and everything go away. So we're not quite there yet, though. In your text editor, you should be able to see that here between the num and the p, that's a tab. Your text editor can show those as well. And so I can come here And I can say show the invisibles. And so now this little diamond shape here means that that's a tab. When I take things from Excel into a text editor, it's automatically tab delimited between those two cells. But remember, the num was in one cell, everything else was in a different cell. But now I've got to come down and see my answers here. And so remember, I've got the little star, the asterisk delimiter. And so what I'll do is I'll find, and I could just do it for these small ones here. I could just go in and do it by hand. But if I've got 500 of these, which I typically do, I would say, okay, go ahead and find that. And then I have to change it into a tab. And so in my text editor, changing it into a tab means \T. So then I can come down here and say replace all. And so if I do that, okay, so now I can look and I see over here that these are all replaced to a tab now. Okay, so we'll save that again. And then we'll go import this into BlackBoard. All right, so now I've come to, I've just made this test pool in BlackBoard, or if you're using Canvas, I'm assuming it works the same way, or whatever. You might have to change what the text file a little bit, right, to use the format that your LMS is looking for. Okay, so now in BlackBoard, at least, I can come over here. I can say upload questions. I'm going to browse and look for that file, and I know that file for me is in my general chemistry. And so here it is, osmotic pressure. I'm going to choose that file. I like to make the default points 1, so I always put that there. And so now I can submit. And so now I've got all of these problems in this pool. And so I can look at the full text just to make sure that it's formatted correctly. So here we go. An unknown compound with a mass of 0.250 grams is dissolved in 159 mils of water and has an osmotic pressure of 64.4 millimeters of mercury at 24.6 degrees C. Calculate the molar mass of the unknown compound in grams per mole. Report your answer at 3 significant figures. There's R, there's the conversion. Now at this point, it's always a good idea to actually then do one of these problems, right? So you're not looking at Excel right now. Do one of these problems just to make sure that you get the right answer. Okay, and so I would go, well, let's see. I'm pretty sure that I laid out my equation right on paper, right? So I go back to that and I say, okay, so 0.25 grams times the gas constant times the temperature. Temperature, it says, is 24.6 plus 273.15. Okay, and then I divide by the volume in liters. Well, volume in liters is what, 0.159, so divide by 0.159, and then divide by the osmotic pressure in atmospheres. So it looks like we divide by 64.4, multiply by 760, and I get an answer to 3 significant figures of 453 grams. So at this point now, at least in BlackBoard, I can click here and it'll show me the problem with the answer. So I calculated 453, it gives me 454. And so my guess, and so I probably should have used the rounded numbers because that's what the students will see. And so I probably should have done that. But the process is the same. Once you get into the rhythm it's actually pretty straightforward. So so it's not too bad. Please feel free to ask me questions. I am, I'm fine with that. I'll probably post this as a YouTube link. Feel free to share it with friends that might be interested too. All right. Okay. So that's it. Let me know how it goes.